napot kívánok! Szeretettel köszöntöm a hallgatóságot. Tekintsék meg bevezetésként a Frecce Tricolori repülő alakulatnak a varázslatos régi bemutatóját. No, hát igazából ez csak egy rövid képi illusztráció a magyar-olasz barátság és együttműködésnek a bemutatására. Hát igazából ugye ez az előadás felépítéséből is látszódni fog, hogy mi félig olaszok, félig magyarok vagyunk, és hát a cégről egy pár szót szeretnénk bevezetésként szólni, bár valószínűleg aki visszatérő vendégünk itt a konferencián, az már láthatott minket. A CL 38 éve létező cég, gyakorlatilag a biztonsági energiaellátás kutatásában, fejlesztésében és gyártásában jött létre annak idején, ami tevékenység kiegészült az utóbbi időszakban a megújuló energiaforrásoknak a témakörével is, tehát ezért azt mondhatjuk, hogy két profilúak vagyunk, energiaellátás intelligensen, biztonsági, illetve megújuló energiaellátás. Hát röviden egy pár szóban a CL-nek a története, mielőtt rátérnénk a konkrét centrálinverterek bemutatására. 38 évvel ezelőtt Enrico Pensini úr, a Glauco Pensini úr édesapja alapította a céget, Milánó mellett Trezzano Rózában. Aztán ugye az évek során nyilván fejlődött a cég, leányvállalatok jöttek létre. A 2000-es év volt egy fordulópont, mert akkor lépett be a szünetmentes áramellátás mellé a fotovoltaikus inverter fejlesztés, gyártás, és aztán a világban megkezdődött ez a, mondhatjuk, hogy sikertörténet. Közben nyilván a tudományos technikai életben is részt vettünk, az olasz Assosolare szövetségnek az egyik alapító tagja a CL, ugye egy tudományos műszaki szövetség, és hát aztán megkezdődött a világban az egyre nagyobb erőműveknek a fejlesztése, telepítése, gyártása, de a CL nyilván az inverterek oldaláról, az inverterállomások felől lépett be. Hát ugye az különböző gyártmányok jelentek meg, azt majd Enrico, illetve Glauco kollégám majd bemutatja, hogy jutottunk el a centrálinverterekig. Illetve hát talán még annyit mondanék itt az utolsó évek kapcsán, hogy a pandémia ellenére azért nem álltunk meg. Hát 2018-ban még egy békeév volt, mondhatjuk, akkor Kolumbiában egy 80 megawattos fotovoltaikus rendszert szállított és telepített a CL, amellett, hogy persze a szünetmentes tápegységek is mindig megmaradtak a palettán. A tavalyi év, hát az ugye mindnyájunknak a járványról szólt, és 2021-ben az első nagy centrálinverteres magyar rendszert valósítottuk meg, egy 10 megawattos fotovoltaikus rendszert, amiről majd kicsit bővebben is fogunk beszélni. Hát alapvetően ugye a termékeink a szünetmentes tápegységek, illetve a napelemes fotovoltaikus inverterek, illetve hát az ezekhez kapcsolódó adatgyűjtés, intelligens követés, és hát a karbantartás távfelügyelet szervíz. És hát itt akkor átadnám a szót kollégámnak, aki a továbbiakban a centrálinverterekről beszél. Glauco, it's your turn.
Good afternoon, everybody. Thank you, Julie. Let me start also the presentation. Okay, I hope that everybody could see. Hold on just a second. Okay, perfect. So today I would like to focus a little bit on our three-phase inverter, of course, the big ones, so the 1500 VDC. Let me start saying that these are the main important characteristics. Of course, I've tried to recap as much as possible, but then there are plenty of others. So first of all, we have got 4 independent MPPT. There are 4 different kind of power rate cores. Of course, are the same enclosure, so does not change the dimension of the cabinets. And we could put in parallel, so for building a complete power station. And it's extremely easy for going and doing the maintenance or the startup. So first of all, I like to explain you why in the same cabinet we have got a different power. Everything depends on the output. So we have got 3 different outputs because these inverters are studied to be connected directly into the primary leg of the medium voltage transformer and then selling or using medium voltage energy. So we have got 3 different outputs for 640 VSC or 600 or 530. These characteristics are not really important when we design the output, but are extremely important, like some of my colleagues that were saying before, when we connect with the modules, with the PV modules, with the solar modules, because of course we could increase the power from 1100 kVA up to 1,400. So like you can see, there are over 300 kVA more power just by using different the energy coming from the DC. The other extremely important features is the ventilation. You know very well that the worst enemy of a solar park is the sun. Oh, well, let me say is the heat, not really the sun, because everything that we transform, we produce heat. So having the correct cooling, the correct ventilation could increase a lot the efficiency of the inverter. So how we have solved this problem? We have solved it, first of all, by using the master and slave configuration. By this way, if the irradiation, especially early in the morning or late in the afternoon, is not so high, we just run 50% of the nominal power. And this, of course, let us increase a lot the efficiency of the total system. These have got usually a problem because when you work master and slave, it could happen that you have got a master and a slave and then they are not communicating very well. Well, every board that we are mounting could be simultaneously or master or slave, so that if there is a failure, the system will keep working on this way. And then, of course, we have got the ventilation. Like I was telling you, we inspire the air with the different kind of speeds, thanks to our very last technology fans system. And by this way, we could work without any problem. And I could show even installation all around the world from -25 up to plus 60 degrees. And this talking about temperature, room temperature. Now, like just shortly what I've described before, we have got the bus that is keep synchronizing all the modules. So by this way, the eventual noise when we put more inverters or more modules in parallel is totally cancelled. And this, you know better than me, that means that we will not have weird waveforms and so on. Then we have got mounted by series. Of course, a customer could also decide not to mount that, but we rather prefer having the automatic motorized DC disconnector, because by this way we could easily ground the system. So when there are modules that are asking some kind of special features about grounding, or a big, huge problem that during the day we have already explored, so the PID, these will help a lot because we could ground it much more better. And then, like I was telling, by having the modularity, we could replace easily every kind of problem without having troubles. Some other features, we are particularly proud of our extremely compact dimensions. Of course, we have got a different kind of communication ports, something very, very simple like a USB port that will be useful for the technician, the service people, just to update eventually new norms or latest features and so on. And then we have got also a peer-to-peer communication Modbus, by which we could, especially when you're talking about power plant controller, so when we talk about a big installation, is extremely recommended by the utility, not really by CL, but the utility are asking to have a power plant controller and a SCADA. Of course, I'm not mentioning, but all the inverters are fully certified with the safety, EMC, grid codes and so on, so that is not an issue, but I like to underline. Some little explanation about the 3 levels, because how we have been able to reach this kind of features. First of all, despite practically all our competitors, we are really using the correct IGBT. So we use the Power Semiconductors 1.2 MV rated. That means that practically we are already able to reach 2400 volts. Meanwhile, a lot of our competitors are not even able to reach 1000 or 1002. This, of course, it means that we are spending more, but for our customer and for achieving this kind of efficiency is a must. So very often people are declaring features, but they are not able to reach this kind of numbers. Of course, these by having the same kind of IGBT, we have got a lower peak-to-peak value for a common output current. We have got, of course, a lower harmonic current distortion, but we could achieve an incredible high efficiency, conversion efficiency, and practically nothing or very low leak of currents. Just to show you, these are real numbers or real measurements done with our old technology, that is the 2 level, and the new technology, the 3 level. So like you can see, everybody of you is an engineer, you could immediately notice the difference. Let me say the one that I am much more common, also because also with the UPS or with the loads is the biggest problem, are the harmonics. Like you can see, the total harmonics is, for phase is practically nothing, is around 0. These just to give you some numbers and some features. The fully IGBT system also allowed us to protect any signals coming from the other gates. So this practically is a common problem of the saturation when you have got every overcurrent to IGBT. By this way, of course, we have solved this problem. Another big problem is where there are all the junction of the IGBT. Again, by having this hardware, we have been able to have a temperature exactly in the junction point that is extremely low. And this allows us to use the ventilation system that I was telling you before in a very high system and a very value system, because practically we will run the ventilation only when the temperature is very, very high. Meanwhile, usually if we are around 20 degrees, practically the whole inverter is, so at the end of the day, practically cold. Other firmware things are, of course, the protection on overload, and we have got the capability to read the grid voltage out of range, and so to stop or to allow the inverter keep producing in accordance to the local grid code. All of these, what happens? Happens that when we're talking about the performance, again, if you think during early in the morning or late in the afternoon, or even a lot of inverters, competitors' inverters have got the problem when there is a very high temperature, they are not able to achieve the 100% of the nominal power. Well, us, we are even able to guarantee over 10% in some cases even 20, depends which is the real temperature in that moment, without any problem. So when we are talking about kVA or kilowatt, for us is absolutely the same, because the real power is always above. Of course, when we are talking about Hungary, there are not such big troubles with the temperature, because summers are like here in Italy, are normal temperature, meaning that we never reach 60 degrees temperature, ambient temperature. But in some other ambient like Middle East, North Africa, Central of Africa, or South America, this is a very common problem that we have solved without any problem. Let me give you here, all these features are fully certified and tested by international laboratory like TUV. And so you can see that the peak is always, in every kind of configuration, 99.67, sorry. The Euro efficiency is 99.33 or 99.39. So again, we are talking of an extremely high efficiency. But why? Because the MPPT is very high. When we talk about the dynamic one, we reach 99.8, and with the dynamic 98.78. Long story short, it means that if you install 10 megawatt modules, we reach 9,999 kilowatt hour production in every kind of condition. You could guess that, or you could questioning that there are some weak points. Well, of course there are, because are the components. But usually in the inverter is expecting for living like 25 years. But of course you have to keep the after sales service. This is why, like for instance, before was talking Jury, that is my official and unique distributor in Hungary, we have got a capillary O&M or companies that could provide O&M worldwide, and this is extremely important because we could give to any one of our customers all around the world the correct support. There are in any case some components that needs to be replaced, like the fans, usually once every 10 years, the surges usually once every 5 years, the DC capacitors every 10 years, and the AC filters every 10 years. Be careful in any case that these are calculated on a standard condition. If the grid is very full of distortion or noise, of course the life of such kind of components could decrease. I could tell you, I don't know, for instance, in South America, usually they've got a grid that are very poor as quality. So instead of replacing the DC capacitors in 10 years, usually we are replacing after 7. That is still very good, but you have to keep this in mind. In Hungary, I could tell you that usually the grid are very, very good. And so this problem will not be very present unless you are the last company after a medium voltage point, and so maybe you are taking all the noise, all the distortion coming from all the other companies, and so could happen that you have got that problem. Then we have also done a recommendation about when doing the service. So for instance, cleaning the filters, the high filters and so on, at least once a month. I don't know, checking the fuses at least once every quarter, or checking about the corrosion and so on once every year. Just keep in mind that if you do the correct service and so on, you have got a loss of production that is below, much more below 1%. So it means that you have got a very high MTBF, but also a very high MTTR, and this means that practically you will never really stop the installation. If you don't do that, of course, the loss of production could be higher. So here I'm not talking about the number coming from the inverter, but I'm talking mainly of the numbers coming from the grid and from the lack of service. Now, which is the best solution? There is not a best solution. The real answer is it depends of the needs of the customer. And the needs of customer are coming mainly, because we are grid connected, so are coming mainly from the condition of the grid. So first of all, we have to decide which is the best sizing. This is why us as SCL are giving, free of charge of course, a complete support in configure the best solution together with the engineer or together with the customer. Why? Because the number of modules, PV modules, 10 megawatt is 10 megawatt. I mean, it depends on which is the size of the module, and so you will have that exactly number. But
excuse me, Mr. Penzini, please try to summarize and close the presentation.
Okay, I go and I will just going shortly to what we have done right now in Hungary.
Thank you.
So let me say, of course, you could put all the inverter together inside of a container. And so, for instance, this is what happens. This is a 3 megawatt installation for a total of 10 megawatt that is composed by 3.2 MV transformer, 6 inverter of 1.5 mega, of course, the monitoring system, and the low voltage and medium voltage cell. Long story short, if you need help and support, SCL is the correct partner that could help you in deciding which is the correct solution for your site. That's it.
Hát akkor tulajdonképpen összefoglalnám csak azt, hogy ugye centrál inverterekről beszéltünk. Magyarországon itt vagyunk a SCL képviseleteként nagyon régóta, 1990 óta, és talán azt szeretném elmondani, hogy itt rengeteg referenciánk van, de a legutóbbi 2019-es még élő konferencián akkor beszéltünk róla, hogy Magyarországon milyen komoly fejlesztések előtt állunk, és hát ezt most akkor névvel a JASZ Plastiknál valósítottunk meg, és illetve most van velünk megvalósítás alatt egy 10 megawattos erőmű, amiről Glauco is beszélt, ugye ez 3 darab inverterállomás, egyenként 3056 kW-osok, 22 kV-os transformátorokkal, és ugye ez egy vízfatvédelemmel ellátott naperőmű. De mindenképpen szervezünk majd oda egy tanulmányi kirándulást, erről szó volt, hiszen ez egy nagyon, nagyon szép és érdekes dolog, arról önmagában lehetne órákig beszélni. Itt az alapítóval ünnepeltük annak idején 2 évvel ezelőtt a jeles évfordulót, és hát állunk rendelkezésre, és köszönjük szépen a figyelmet, elnézést, hogy kicsit kifutottunk az időből. Köszönöm szépen!